It is part 2 of section 1.5, solutions of non-homogeneous linear systems. Let's try to solve this problem first. Describe all solutions of ax equals b where a and b are given in this way. To solve this problem, we'll begin with the augmented matrix. Okay, here. Now the augmented matrix is A and B. Okay, A is 3, 5, and minus 4, and minus 3, minus 2, and 4. And third row is 6, 1, minus 8, and right side is 7, minus 1, and minus 4. Okay, from this one, okay, we can eliminate, okay, this is pivot, and we can eliminate this one and that one. So we keep the first row the same, 3, 5, minus 4, and 7. Okay, second row, by adding the first row, we have here 0, and now 3. By adding, we have a 0. By adding, we have a 6 here. Okay, twice subtraction will make a 0, and twice subtraction, that is now minus 9. Twice subtraction, so 8 is added, which will make 0, and twice subtraction, minus 14, that will become minus 18. Right? Okay, from here, now this is a new pivot, and if you subtract 3 times of this row from the final row, then it'll be 0. Okay, now we scale it, and here, so we put here 0. So we can see here now 3, 5, and minus 4 and 7, and 0, 1, and 0, 2, and final row is 0, 0, 0, 0. Okay. Now, to get a reduced echelon form, we have to eliminate this one and scale. Okay. Okay, here now. So first we eliminate by multiplying 5 to this row and subtract. So the 3, 0, and minus 4. Now 5 times subtracted, so that will be minus 3. Okay. And then this is 0, 1, 0, 2, and that is 0, 0, 0, 0. Okay. Now divided by 3 of the first row, then we reach at 1, 0, and minus 4 over 3, and minus 1. This is 0, 1, 0, 2, and 0, 0, 0, 0. Okay, this is the first pivot, and that is the second pivot. Okay, this is the echelon, reduced echelon form. Now for this reduced echelon form, and we can get the algebraic system. Okay, x1, of course x1, x2 are basic variables, and x3 is the free variable. Okay, so x1 is the same as now constants and free variable to the right side. So there is a constant is minus 1. If it is moved to the right side, then that is same as 4 over 3 x3. Now x2 is simply here 2, and x3 is a free variable, so we can write down here that is x3. Okay, from this one, now the solution x1, x2, x3 is same as a constant vector minus 1, 2, and 0, and plus x3 is a free variable, and then direction is 4 over 3, and the second one is 0, and third one is 1. So that is the general solution. Is constant plus x3 can be chosen as an arbitrary number and this vector. So that is a line passing this point after moving that amount, and then here from that one, now in the direction line can be made. If x3 is a negative, then opposite direction. So in fact, the line is whole line. Okay, so that's the general solution. Now, the solution of the example is of the form x is p, constant vector times x3. We may consider x3 as a parameter t and a vector v. Of course, we call this one v. So, that this is an equation of a line through p parallel to the vector v. Okay, so we call v is the direction vector. Now, in this in the previous example, the solution of ax equal b non-homogeneous system is x equal p plus tv. Here the question is, what is tv? To figure it out, and first we consider here ax, that is ap plus tv. Okay, we can separate out and equals b. And here, x plus p tv is a solution even when t equals 0. So that we choose t equals 0, then this term becomes ap. The right side must be b. We compare now these two equations, and we can conclude this term is 0. A tv equals 0. That implies that tv is a solution of the homogeneous equation ax equals 0. In general, we can claim this. Suppose the equation ax equals b is consistent. First of all, the system should have at least one solution consistent for some given b, and let p be a solution. This is any constant solution. Then the solution set of ax equals b is the set of all vectors of the form w is p plus u sub h, where u sub h is the solution of the corresponding homogeneous equation ax equals 0. Okay. So we have corollary. Ax equals b has a solution, then the solution is unique if and only if the corresponding homogeneous system has only the trivial solution. Because the solution, general solution, is made in this way. Constant vector plus the solution from homogeneous equation. Right? Okay. Now let's see true or false problem. The solution set of ax equals b is the set of all vectors of the form p plus u sub h, where use of which is the solution of a homogeneous equation ax equals 0. Is it true? It is false. Why? This statement is too vague. The given system may not have solution. Then if we try to write in this way, then it's wrong. And to get the solution in this form, first of all, the system should have at least one solution. It's consistent for some given b, and we have a p, constant solution. Then we can say the middle part. But for this statement, there's no the assumption for consistency, so it's wrong. The equation ax equal b is homogeneous if the zero vector is a solution. Is it true? It's true. If zero vector is a solution, that means that ax here, if we put 0 here, then no matter what it is, b must be 0. This assumption, the zero vector is a solution, implies that right side is 0. So ax equals 0 must be homogeneous. So this statement is true. The solution set of ax equal b is obtained by translating the solution of ax equals 0. Is it true? Again, it is not true. And here, in fact, the theorem is saying that once the system has at least one solution so that it is consistent, then now the solution set of the system is the translation of this solution. The p is translation vector. So that is true when we add here the condition that this system is consistent. But without saying consistency is wrong, because from the beginning, it may not have any solution, so that in the case we cannot say this part. So it is false. Through these true or false problems, I hope you can get more thorough the concept for the linear algebra tasks. Okay, that's the end of the section. Thank you.